And now let's look at problem 23. So consider the series whose terms are the reciprocals, you're dividing by, of the positive integers that can be written in base 10 notation without using the digit 0. And show that this series is convergent and the sum is less than 90. Now this is why it's called Problems Plus. This is pretty next level. Alright, so let's take a look at the solution. So let's call this series, again, whose terms are the reciprocals of the positive integers that can be written in base 10 notation without using the digit 0. So let's call this series S, and we can group the terms according to the number of digits in their denominator. So S is going to equal 2. So the first set, again, has to be without a 0. And the reciprocals of positive integers. In other words, we're going to have a scenario 1 over 1. That's a reciprocal of 1, it's 1 over 1. And then plus, then the second is number 2, positive integer. Divide that, so reciprocal of that. Plus, dot, dot, dot. Then we're going to get a plus 1 over 8. Plus 1 over 9. And this, we can't get any further. We can't go 1 over 10. That's a 0 inside. So we'll stop this. I'm going to call this segment G1. And now the next one's going to be plus, and now we skip the 10. So it becomes 1 over 11 plus dot, 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 all the way until we get 1 over 99. So we get, so we get 11, 12, 13, 14, 15, 16, 17, 18, 19. Then we skip the 20, then we go to 99. And this one we'll call this group 2 or G2. And so on. The next one's going to be with 3 digits. With 3 digits, the lowest one's going to be 1 over 1, 1, 1 plus dot, dot, dot plus 1 over 9, 9, 9. And then it keeps going on and on. This is G3. And now here I just made it smaller to fit in here, and then we're going to write plus dot, dot, dot so you see the pattern. Alright, so now let's continue further. Now let's count out the number of terms. So now in group Gn, since we have 9 choices for each of the n digits, so each one of these, for example, this 1, 1, 1, each of these could be 9 different choices. In the denominator, there are then 9 to the n terms. For example, I'll just write IE. So for example, for G1 has 9 to the 1, which equals to 9 terms. And this is just, well, 1, 2, 3, dot, dot, dot. Yeah, this goes all the way until 9. So this is 9 terms to illustrate it. This is 9 terms. I'll just put that here. We get 9 terms. All right, and so that's what we have there. And then G2, so the second group has, well, has 2. It has 2 digits in each of the denominator. So then this has 9 to the squared, which equals to 81. Yes, in other words, it's going to have similar, to the other one. So the first one's going to be 1, 1, 1, 2, 1, 3, dot, 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 until 1, 9. So it's 9 terms there. And then it's going to go, well, the next one's 21, and then dot, 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 all the way until, well, 29. And then it goes all the way down until we get 91, dot, 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 all the way until we get 99. In other words, this all the way down here, this is how many rows? This is 9 rows. So we have 9 rows of 9, so 9 times 9. 9 rows. And yeah, you can see that. And then similarly to G3, you're going to add another dimension to it. So this has 9 cubed, which equals to, I'm not going to solve that, just go 1, 1, 1 here, then dot, 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 all the way until 1, 1, 9, and then we have 1, 2, 1, dot, 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 all the way until 1, 2, 9, and then this goes all the way down, then this goes all the way down, total is 9 rows, or better yet, just make it all the way down here, so dot, 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 all the way until 1, 9, 1, and then dot, 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 all the way until this is 1, 9, 9. So that's 9 rows. So we have 9 times 9, and I'll just say this is 9 rows. And we got to do this again. Then do then do starting from 211 all the way down until 291. And then that's again 9 times. Then do 9 again. Yes, so 9 times again. Yeah, do this 9 times total. Yeah, and then yeah, basically do that each time. So this is 9 times 9, and then times the 9. And then as you can see, this keeps expanding, and so on. Alright, so furthermore, each term in the group Gn is less than 1 divided by 10 to the 10 to the n minus 1, except for the first term in G1. In other words, well, let's just look at this. For n equals to 1, we have 1 over 10 to the power of 1 minus 1 equals to 1 over 10 to the 0, which equals to 1. Yeah, so thus we have the first term is 1 equals to 1, which equals to 10 to the n minus 1. But we have the next term is 1 over 2. Yeah, the next one 1 over 2. So notice this one here, 1 over 2. So, but 1 over 2, yeah, is less than 1. So it's less than 1, and then dot, dot, dot. We also, then the last term is 1 over 9. It's also less than 1, because you're dividing by a number bigger than 1. So, and then for n equals to 2, what we have is 1 over 10 to the 2 minus 1. This equals to, yeah, so for n is 2, yes, then we'll have 10 to the 1. Yes, in other words, this is just, yeah, 10 to the 1. And what this means is, well, the first term in that group, 1 over 11, this is less than 1 over 10, because you're dividing by a bigger number. And then all the way till 1 over 99, this is less than 1 over 10. And then you can keep doing this on and on. For the n equals 3, it's going to be less than 100, or 10 to the 2. 10 times 10 is 100. So I'll put a dot, 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 etc. Dot, 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 etc. Thus, Gn is going to be less than 9 to the power of n. That's a number of terms. So I'll put this here. Alright, so this is 9 here. This is number of turns. Alright, number in each group, number of terms. Yeah, so that's the number of terms, and then basically it's going to be, well, times it by the max size, that is 1 over 10 to the n minus 1. In other words, every single term is less than 10 to the n minus 1. So then we can just multiply the total number of terms. So each group will be less than total number of terms times here, and this is our max size. That's only for G1. I'll put this here as, let's put this as max size here. So that's the number of terms times by the max size. Or better yet, I'll do this. Max size. Max size, and it's only for the first term. So everything else is going to be less than it. And yeah, so then, yeah, that is that. Then we can simplify this further, or just write the 9n right there as 9 times 9 to the n minus 1. So this is 1. So you can add those up. This becomes 9 to the power of n. This is times it by 1 over, or I'll just divide this by 10 over 10. 10 to the n minus 1, which equals to 9 times 9 over 10 to the n minus 1. And here I just move things around just to make it a less congested. So that's what we have so far. And now note that S, the sum is well, you can write it as summation of from n equals 1 up to infinity of Gn is less than a convergent geometric series, which is this right here. And that's because this absolute value of r is less than 1. So in other words, I'll write this all out. S is equal to the summation from n equals 1 to infinity of Gn is less than the summation from n equals, we'll go n equals 1 of 9, up to infinity of 9 times 9 over 10 to the power of n minus 1. And if you just write this out, if you put a 1 inside, this goes to 0 of a 9 plus, and then put a 2, this is power of 1 there, we'll have a 9 times 9 over 10, and then plus the next one 9. Then if you put a 3 there, they'll be squared. 9 over 10 squared, and so on. Put a 9 over 10 squared plus dot dot dot. It keeps going on and on. In this case, this is going to be our A, and this is our R, which equals 9 over 10, which is less than 1. So in other words, this is convergent. Yeah, so it's less than 1, therefore the whole thing is convergent, like that. And then we could write this using the formula. So in other words, S is less than the sum of a geometric series, 1, which is A divided by 1 minus R, and then this equals to A is 9, and then divided by 1 minus 9 over 10, and then multiply this by 10 over 10, so we can subtract, which again, that'll just be 10 minus 9 is 1, so basically we get this equals to 9 over 1 over 10, and move the 10 on top. That becomes, I'll just move this downwards, or better yet, I'll just move this out of the way and then move this R there, move the convergent over there. So this equals to, move the 10 on top, equals 90. Yeah, so there's our answer. And this is exactly what we were asked to show. We were asked to show that the sum is less than 90. Well, I just put a check mark there and just go review that again. So going all the way back up here. So again, we were asked to show that the sum of the series of the reciprocals of positive integers that exclude the digit 0, and yeah, in base 10 notation, that show that this series is convergent and the sum is less than 90. So it's convergent and it's less than 90, which is quite fascinating there.